continue this great story. Yeah. Yeah. All right. All right. So here I like to use the development of this method to show you some general problem-solving procedure. Yeah. Here, what you see is a typical problem-solving procedure. Okay. Yeah. For mathematicians, they frequently need to do things like this. Yeah. Yeah. Here, at this step, we get a y prime, the expression we feel too complicated. Yeah. Even for mathematicians, they also feel too complicated. Yeah. All right. Yeah. So if we work on these four terms directly, then nobody can handle it. Okay. So you have to simplify it. All right. Yeah. But question is how to simplify it. Yeah. You have to find a smart way to simplify it. Yeah. Here, remember, when we introduce u function, v function, we have a lot of freedom there. When you have a lot of freedom, how do you use your freedom in the right way? How do you use your freedom to make your life easier? That's the decision we need to make at this point. Okay? Yeah. Good. Yeah. So, yeah. All right. Next, let's make some observations before we make next move. Yeah. Four terms too complicated. Our first observation. Okay. Yeah. Second, we have a lot of freedom in u function and the v function. So we need to try, some smart way to use the freedom. Okay. Can we take advantage of the freedom to simplify the above four-term expression? Yeah. So that's the, direction. We need to use our imagination to make a very brave assumption. All right? Yeah. All right. Question: how to simplify the four-term expression? You're allowed to make assumption. Okay? Because you have a lot of freedom, so you have a lot of room to make your reasonable assumption. Can you think about what kind of assumption you want to make? To make it, so here, the goal. Yeah. No idea. No idea. The goal is get fewer number of terms.
Make something like 0.
Yes, make something 0, but which part you want to make them 0? That's the question. Do it right way, okay? Not wrong way. Okay? Yeah. Look at the structure. Each term. Try to, compare the terms. Try to see some special properties in the structure, the terms. So you make some of the terms 0. Look at that. Okay? All right. Let me write four terms. I group them into two groups. Yeah. Group the likes. Yeah. Why I group these two terms? Because I treat them the like. Yeah. They have the similar structure, right? Yeah. y1, y2 prime, u, v function. Right? u prime, v prime, y1, y2. So they have the similar structures, right? Yeah. So the terms with similar structures, we group them. We put in one group. So we group the likes. They are like in some way. Yeah. Okay? After this grouping, yeah, so we know in math, grouping is very important. In problem solving, grouping, smart grouping, very important. Here, we make this critical grouping. After this grouping, then make assumption. Which part you want to make 0? Good. Yeah. U prime, he says, make this part 0, not that part 0. Yeah? Because you have only two options, right? One of the two parentheses 0. But because his reaction is very fast, so he feels that's the natural way to make U prime, V prime group 0. Can you feel about it? Try to feel about it.
Well, I mean, we are under the assumption that we already have y1 and y2, so it's easier to figure out u and v. We can take the derivative of y1 and y2, but we don't have u or v, so we can't find u prime or v prime yet.
Yeah. All right. Yeah. So, right. Okay. Oh, sorry. Yeah. Right. Yeah. Because here it's prime. Yeah. Here the prime, right? So here, so this part, yeah. Because here we are working on the prime structure. So here it's better to have the same y prime structure, uv treated as the coefficient part. Okay. All right. But here the structure is, quite different from that one, right? Yeah, because the function value, here the derivative, function value, so this group, the structure is quite different from yp prime. Here, the structure closer to prime, right? Yeah, because y prime, another y prime, this is y prime, right? So the structure is similar. So that structure not similar, so we treat as the, outlier. How about that? Yeah, something, different from the group. Okay, yeah, outlier. All right. So when we make assumption, some part 0, can we make the outlier part 0? Yeah, outlier. We don't want to make the mainstream 0, right? Yeah. So we want to make the side part 0, right? Side part. Outlier, side part 0. Mainstream, we'll keep it. Okay? Major part, we should preserve the major part. Okay? Yeah. So here, the major part. All right. Then we make assumption. Like that. Yeah. Further assumption. U prime y1 plus v prime y2 equals 0. We assume, we force it to be 0. Question, how can you force it to be 0? How can you force it to be 0? Because we have a lot of freedom. Yeah. U prime, V prime, a lot of freedom there. Okay? When we have freedom, we can do it. Okay? Yeah. So you can see, how do we use the freedom we have? All right. Yeah. So we simplify. Yp prime now becomes the two-term expression. Is it much better? Yeah. So now you feel it's not that scary, right? Yeah. Yeah, still ugly. Yeah, but two terms, that's a big improvement. Yeah. Big improvement. Yeah. Yeah. If you want try to make one term, no, that's not good because you reduce your freedom. Two terms, you have a lot of freedom, right? If one term, too restrictive, then you may not get solution. You may not get solution. So you have to apply some balance principle. Balance principle. Okay? Not go the left extremo, not go to the right extremo, somewhere in the middle to control the balance of all factors. So that's what we are doing. Okay? Balance law, balance principle. Yeah. All right. Now, so let's continue. Okay? This time we have the new assumption. After that new assumption, our yp original form, yp prime, that form, then we can take second derivative 4 terms again. Is this scary? Second derivative 4 terms. But that's the last one. Because we don't need to take, third derivative. So that's the end. Okay? That's the end. We have 4 terms. We just take it. 4 terms. We just take it. Because it's the end. Already end. Then the middle one, y prime in 4 terms. Because we need to, if we take double prime, how many terms? 8 terms, right? Then we don't like that. Okay? Here, 4 term, because that's all we need to have. So we just take it. All right. Then, in order to use the left-hand side format, we need to multiply p both sides of y prime equality. P multiply y prime equality. So we get this one, p. Okay? All right. Then q multiply yp equality, both sides. Q. Yeah, because the left-hand side formula tells us to do that. Okay? Left-hand side formulas tell us we should do in that way. Okay? All right. Then we added these 3 equations. We add these both sides, these 3 equations. Left-hand side, right-hand side. Can we combine all the terms with u factor? U factor, here. Let me circle out. All terms with u factors, this group, okay? Sorry, this group. This is one group, okay? All terms with v factor, this is another group. 2 groups. Can you see that? Okay? Grouping, okay? All right. The first grouping, we can factor u out inside parentheses. y1 double prime, p y1 prime, q y1. What's this? What's this? Homogeneous version. y1 is the one solution of the homogeneous equation, right? So this equals 0, right? Homogeneous solution. y1. Okay? How about this? y2. V factored out. y2 is another homogeneous solution. Right? Can you see? Our assumption, y1, y2, the 2 homogeneous solutions. y1, y2, 2 homogeneous solutions. So conclusion, the first parenthesis equals 0, second parenthesis also equal to 0. How about that? Greatly simplified, right? Okay, can you get this step, simplification step? Homogeneous assumption. Any question? If you cannot understand, you ask me question.
What's allowing us to equal to 0 again? Just because
Yeah.
if we have freedom with the UV.
Here, nothing to do with UV. For any UV, this parenthesis must be 0, that parenthesis must be 0. What's our assumption about y1, y2?
That we have solution.
y1, y2, 2 basis functions for this homogeneous equation, right? Equals 0. Homogeneous, what's the homogeneous? Replace R by 0. Yeah. That means when you plug in y1, y2, must be 0. Both must be 0. We just use this property. We don't want to waste these 2 precious properties. Right? We just apply the properties. Okay? Yeah. After that, only these two terms left. But this whole thing equals our function. Question.
So you're saying that, so the y1 double prime plus py1, you're saying that because it is basically synonymous with the standard form, the homogeneous form, that we are allowed to say that it's the same, so we can assume it's 0? Is that what you're saying?
Not that. Yeah. All right. Let me go back to our assumption. Yeah. So all right. So yeah. Let me just yeah. All right. Read this. Assume that y1 and y2 form a basis of solution of homogeneous solution. Here, what I mean, the homogeneous. Yeah? Yeah? Yeah. All right? So it's not like magic, We have before. Okay? Yeah? All right? All right. Good. Yeah. Good. All right. Yeah. All right. Now you agree. These last two terms must be our x function, our function, right? All right. Then let's clean up. Okay. Try to write the thing in a clean way. Okay. Yeah. That's our assumption. Remember, look at this assumption. We just copy that assumption. Okay. Don't waste it. Okay? Don't waste it. Let's copy it. All right. The first equation, second equation, this one equals our function. Observe this linear system. Is it linear system? Can you see? Can you identify as the linear system? What are variables in this linear system? Can you tell me what are coefficients? What are variables? Linear system. Unknowns. What are unknowns? What are knowns? Unknowns. All of them? U prime, V prime, unknown. Y1 prime, Y1, Y2, Y unknown, right? Because we assume we have these two solutions, right? So Y1, Y2 are known, U prime, V prime, unknown. Can we solve this linear system for U prime, V prime?
Sure, why not? You got two equations and two unknowns.
Mm-hmm. Yeah? Yeah. All right. If I write the matrix equation, do you feel comfortable on this matrix equation? Linear system using matrix format. Because this 2 by 2 matrix, it's known, right? The coefficient matrix. This vector, unknown vector, right? Yeah. But this vector is known. How to solve this linear system? Yeah. What do we call that -1 thing?
I can't remember.
Inverse. Inverse matrix. We multiply both sides by that inverse matrix. Okay? Do you know how to find that inverse matrix? How? There is a formula. It must be symbolic calculator. All right? Yes. I don't, not the numeric. Because we have symbols here, right? Symbolic. Yeah. All right. Yeah. But here, let me just, because even without formula, we can do it easily. So here I show you how to use the cancellation or elimination method to find the solution. All right. Let's do here. Okay? Two linear equations. Yeah. First time, we want to find U prime by canceling out V prime term of two equations. Do you know how to cancel V prime terms, two equations? Right. This one, how about, because this one we want to, we multiply y2 is here, no y prime 2, so we want to multiply y2 prime to get this one. Okay? The bottom, we want to multiply y2, so then this term the same, right? After multiplication, the same. Same when we do subtraction, can we cancel out? Yeah, subtraction, all right. The subtraction, this side, y1 times y2 prime minus y1 prime times y2. It's W. Wronskian, yeah, Wronskian. The definition, Wronskian. So W, okay? W times U prime equals this. So U prime equals, all functions here are known, right? R known, Y2 known, Wronskian known, right? Wronskian known, okay? Yeah? So what U prime is known, all right? Similarly, in order to cancel U prime term, we multiply Y1 prime, second line, Y1, and do subtraction. Also Wronskian, but a negative Wronskian this time. Do subtraction. Negative Wronskian. Okay? Negative R Y1. Okay? You know, simplification, U prime equals R Y1 over W. Yeah. Then, can we find U and V? We know U prime, V prime. Can we find a U and V? Right, integral. Integral. So we have formulas. We get formulas, yeah. But this formula, UV, we need the final solution formulas. Final solution formulas. YP equals Y1 times this U part, Y2 times the V part. But all functions in this formula are known, right? The good thing is all functions at the right-hand side are known. Although it looks a little complicated, but we can calculate it. We can calculate it. Just we do the calculation slowly, carefully, we can find a solution. Yeah. Think about the whole derivation process. Okay? Yeah. All right. Hope you feel all right. Yeah. Not that messy. All right? Yeah. Later, when you have that problem, just apply this formula. Okay? Yeah.
So we just have to like plug in?
Yeah, plug in. Yeah. Plug in. Yeah. All right. Yeah. Okay. Yeah. Example. Yeah. So let's do one example. Let's solve this equation. Yeah. This time we can apply formulas. All right. Solution. Yeah. Easy part first. YH easy, right?
How did you know to do the part in parentheses?
Oh, how do I know? Oh, how do I know? Oh, from the homogeneous part. Can you see the double root here? Yeah. If a double root, the solution should have this structure. Because you find the root is -3. Lambda. Oh, okay. Yeah, let me write one more step. Yeah, probably a few other students, yeah, have the same question like yours.
Okay.
Double root, okay? That's y plus 3 squared. Yeah, yeah, right. So -3, it's a double root. -3, but when we write a solution for double root, E function, one, yeah, second one use X. Yeah, yes, yes. Yeah. Yes. Right, good. Yeah. There's formula there. Okay? If you need to, you can go back, find the formula. Yeah. Here the only thing is just to find the right formula. That's good. Yeah. Quickly find the right formula. That's what you need. Okay? So you need to practice. Okay? Get familiar with all those formulas. Yeah. Then just find the right place. Yeah. All right. Here, recall. So here I need to write down the formula for myself. Yeah. Because I couldn't memorize myself. Yeah. All right. U, V. If you want to calculate U, V, it's okay. Yeah. Yeah. So let's calculate Wronskian first. Okay? You can see Y1, Y2, right? From this one. Y1, Y2. Right? So Y1, Y2. All right. Then Wronskian this determinant. By the definition of Wronskian determinant. Okay? Yeah. So then determinant, this function. E function. Okay? All right. Then we can calculate U and V. Yeah. All right. U plug in, yeah, all known functions. Yeah, cancellation because, E term can be canceled out. Constant, we take constant out. Y2, because Y2 you have this E to the negative 3x, E to the negative 3x, you get an E to the negative 6x, right? 6x, Wronskian, E to the negative 6 cancel out. So E to the negative 6x is gone. Question?
So the W is in forms of Y1, Y2.
Yes.
W, Y1,
Y1, Y2. Y1, Y2. Good. No, yeah. Let me write it out. Y1, Y2. Yeah. All right? Yeah. Okay. So then the formula, natural log function. Okay. Yeah. All right. V, this one, arctangent. Yeah, because this arctangent. Yeah, yeah, yeah. Here, yeah, let me correct what I did last time. Remember last time I said there is a version, simplify arctangent A. Later I found that A version used in computer science, not math. Yeah. So I go back to math because here we are doing math. Because in computer science, when you call inverse trig functions, you use A sine, A cosine, A tangent. Yeah. Short version. Yeah. But in math, people do not use A version. A sine, A cosine, A tangent. So we should go back to the math version. Okay? Yeah. All right. Yeah. Now, YP, yeah, so YP, yeah, because based on the format of the YP, with U and V, we can write this YP function here. Yeah. Then we combine homogeneous part, YP part, so the final solution should be add these two parts together. That's our final solution. That's our final solution. How about that? That's the way we solve ODE for that type. Second order ODE in that way. Okay? Yeah. All right. Yeah. All right. Good. Next topic, modeling electric circuit. Electric circuit. Now, let's come back to this topic, electric circuit problem. All right. Yeah. All right. First, formulas in electric circuit. Yeah. We learned a few formulas before, yeah, but here we need to add a few more formulas. Yeah. So then for this whole type of questions, so we can solve. Okay? Yeah. So we do not need to use too much knowledge. Yeah. So only this part should be enough. Yeah. All right. Look at this figure. This figure. Yeah. First, what do we call this E part? Electromotive force, right? Yeah. Yeah. Electromotive. Yeah. Yeah. It's hard for me to. Yeah. Whatever it is. Yeah. But this time it's not constant. It's a function. It is a periodic function. Okay. Yeah. Periodic function. Yeah. Then 3 components: R component, L component, and C component. We didn't do C component before, right? Yeah. So this time we need to first get the formulas for C, capacitor first. Then we can, yeah, because these are the 2 basic types components. Yeah. Then we can, solve all questions of this type. Yeah. All right. Then look at here. Yeah. First 2 lines we learned before. Yeah. The third line. Today we need to learn the third line. Okay. Capacitor. C. Capacitance. Farads. The unit farads. Okay. The formula. So what's the formula? Voltage drop formula. When we calculate voltage drop, look at the voltage on 2 points around this component. Voltage drop. Look at the voltage difference between these 2 points. How to calculate voltage drop between these 2 points? Q over C. What's the Q?
Charge.
Right. Charge. Yeah. Yeah. All right. Then, today, the first formula. Yeah, we didn't see this formula before. Okay. First, I, electric current equals the rate of change of the charge. Rate of change of the charge stored in this capacitor. That capacitor can store certain amount of electric charge. Okay? Hold the charge, that amount. Okay? All right. But that charge amount changes as a time of function. Q of t. It's a function of time. Okay? But the rate of change is the electric current. Rate of change is the electric current. That's our first formula. Okay, all right, yeah. Then equivalently, we can write Q of t as the integral of I function. I function. Okay, yeah. Because after we get this formula, we can go back to the voltage drop, replace that Q by this integral of I function. Yeah. Otherwise, we don't know how to handle that Q. Yeah. Here, with these 2 formulas, we know how to handle that Q function. Yeah. All right. Then, to set up equation, we need to use the Kirchhoff's voltage law. Yeah. Kirchhoff's voltage law. Okay? Yeah. I think you still remember a little bit, right? Yeah. This E Yeah, because that's the force part. Okay, that's the force. You know, electromotive force part. Equating the voltage drops across the resistor, inductor, and capacitor to EMF, electromotive force. That's the Kirchhoff's law, voltage law. Yeah. Based on this law, we can set up this equation. Okay, voltage drop of the L component, L times I prime. Okay, because di over dt, that's I prime. Okay, voltage drop for this resistor, R times I. Okay, second term, R times I. Yeah. The third term, voltage drop for the capacitor, 1 over C, the Q, by this integral of the I function equals this E function. How about that? Straightforward translation, right? Straightforward. Okay? Yeah. Yeah. But this integral looks, you know, quite special here, right? Yeah. How do we deal with the integral? Right? In our previous equations, we only have derivatives. We don't have integral and the derivatives in the same equation. Right? How do we remove the integral? How do we remove the integral? Yes, take derivative. Right. Take derivative, it's gone. Right? Take derivative, it's gone. Okay? Yeah. Take derivative version, then the first term, L, I double prime. Because L constant. Okay? I derivative, double prime. Okay? R constant, I derivative. Then 1 over C derivative, it's I integral. Okay? Yeah. Then derivative of the E function, that's this one. Now, let's closer to our standard equation, ODE, right? Yeah, matches our standard. Yeah, we can change, you know, make the coefficient 1, yeah, but very easy to convert it to our standard equation. Second order, linear, non-homogeneous equation. Okay, all right. But there's another version, yeah, another version, because this is Q, I can be treated as Q prime, right? I can be treated as a Q prime, right? Yeah. I prime can be treated as Q double prime, right? So another version we can write in this way. Okay. So these two ways work equally well. But most time we use the first version. Okay? Yeah. Sometimes we may use the second version. Okay. Yeah. All right. Yeah. So that's the, you know, basic formulas. Yeah. Yeah. Then we can apply these formulas. We can solve this type of questions. Yeah. This type of questions. Yeah. All right. Look at this question, problem number 11. This time, 3 components. E function given like that. Okay, yeah. L given, C given, R given, E function given. All right, yeah, yeah. Initial condition, current capacitor charge are 0 at t equals 0. Then we need to find the current function. solving some second order linear ODE. Yeah. Now we are ready to do that, right? Yeah. Yeah. We have all the tools we need. Yeah. Just apply some formula. Find the right formula. Yeah. All right. The first formula, let's take that formula first. Yeah. Yeah. Then the non-constant, so let's do the plug-in the first round. Okay? Yeah. Easy round, first round, you know. L, R, C, all known. Let's put them in, okay? All right. So we get all these numbers. Yeah. Here, I and T, yeah. Here, if we feel comfortable, we do not need to switch to Y and X. Remember, previous a few times when we see equation, differential equation with I, T, I converted to X, Y. But later when we do more and more, we feel more comfortable. We do not need to make that switch, right? Yeah. Because that's just, you know, some habit. So if you get used to it, then we just work on it directly. Yeah. So we can reduce one transition step. Okay? Yeah. So let's work on I and T directly this time. Yeah. All right. Then characteristic equation, left-hand side. Yeah. Yeah. After simplification, we can do the factorization like this. Factorization. So we can write y1, y2 immediately. Yeah. y1, y2. Okay? Yeah. IH equals C1, Y1 plus C2, Y2. Okay? Yeah. Y1, Y2. Yeah. With Y1, Y2, R function, Y1, Y2, we have the formula here. Hey, yeah, before we because we have several formulas we can consider. Yeah. Which one you think easiest here? Easiest way. Which one? Easiest. Look at this function. This cosine function. When you see this cosine function, what's the easiest way to calculate this solution? Yeah. Right. Yeah, particular solution. Particular solution.
Can we set it to 0?
Set.
A cosine.
Right. Good. Yeah. IP use A and so undetermined coefficient. Method of undetermined coefficient. Although that Wronskian that way, if you like, you can also use that one. Okay. Yeah, if you like, both way would work. Yeah. Here we use this way. Here we use this way. Okay. All right. All right. Then we need to calculate A and B. The question is how to calculate A and B. Yeah. Yeah. On our textbook. Yeah. So there is, some symbolic calculation. Symbolic calculation. Yeah. So here I don't repeat that part. Yeah. Relatively complicated. Yeah. So you can read 2 pages. 2 pages, do the relatively complicated calculation. Here I just take the formula. So I just take the formula. Formula for A, formula for B. Then we plug in the numbers. So we get a solution. Okay? We take the shortcut here. Okay? All right. In order to take the formula for A and B, we introduce a concept called the reactance concept. Reactance concept, what's that? Reactance concept combines L and C in this way, omega times L minus 1 over omega C. Yeah. Why you make this symbol? Because in AB formula, we needed this S. Okay? In AB formula, we needed this S. Yeah. Otherwise, AB formula could be very messy. If we use this symbol, we make AB formula not that messy. Okay? Not too messy. Yeah. All right. So let's calculate S first. So here we plug in number. Omega we know, right? What's omega? What is omega? 377. That's omega, right? That's omega. L 0.1, L times 37.7. Okay? 1 over C, C times omega 3.77. Okay? Yeah. So the S number 37.4. So we calculate S first. Then we have A formula. This is the A formula. Okay? E0 S E0, this 110 is E0. Okay? 110. E0. Okay? Yeah. The magnitude of this force, okay? EM force, EMF. So negative E0S, this RS square, all known, we plug in, we get this number, A. And the B, this formula. B, that formula, okay? No, we just, take the formula. Those two formulas. Yeah. Yeah. All right. Yeah. So we have A, B, we get IP, right? Yeah. So we get IP. Yeah. We get IP, IH adding together the general solution. In order to find C1, C2, we can use these two conditions, right? Initial conditions. These two initial conditions. Yeah. Then we can find the solution. Yeah. So here I do not complete that part. Yeah. Yeah. It should not be too hard. Yeah. So Q0. Yeah. Q0 equal to 0. Yeah. 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 So you can try a little bit, okay? Yeah. See if you can get it. Yeah. Yeah. I will also try myself. Yeah. If it's not trivial, then I will talk about it. If it's trivial, then I just pass. Okay? Yeah. Trivial. Yeah. So if the technique I feel everybody knows the technique, then I just skip. If there is some trick, yeah, some special way, then I will talk about it. Yeah. All right, that's it. So we finish module 2. Then next week we will start module 3. Yeah. Yeah. All right. Yeah. So just let you know, when we start module 3, module 1, module 2, we treat as the fundamentals for this class. Okay. After starting from module 3 and higher, then the techniques, I try to go a little faster. Okay, I try to cover the most important topics. Yeah, some details I may skip. Yeah, because we do not have that much time. I just try to cover all the main technologies. Yeah, so some relatively small details I skip. Yeah, yeah, yeah. Otherwise, we cannot finish this semester. Yeah.